Hello everyone, today we are going through important questions of three-dimensional geometry. First question, find the distance of the point 2, 3, 4 from the x-axis. Okay, so here it is three-dimensional plane. Suppose it is a three-dimensional plane, x-axis, y-axis and z-axis. Suppose it is the point, given point 2, 3, 4. Okay, and here we have to find the distance of this point from the x-axis. Okay, so here we need to find this point, right? So that we can apply distance formula. Okay, so here what is this point? See, and we know that on x-axis y coordinate and z coordinate values are 0, right? So here, so what is x coordinate value? This distance is nothing but 2 because it is 2, right? Since it is 2, that is x coordinate value is 2, that means this distance is 2, therefore this distance is 2. So here this point is 2, 0, 0. On x-axis, y coordinate and z coordinate are 0. Okay, so here now we can apply distance formula to find the distance between these 2 points. Okay, that is distance is equal to square root of, suppose x1, y1, x1, y1, z1, x2, y2, z2. So what is the distance formula? x2 minus x1 whole square, that is 2 minus 2 whole square plus 3 minus 0 whole square plus 4 minus 0 whole square. That is equal to 0 square root of 9 plus 16, that is equal to square root of 25 is equal to 5 units. So what is the distance of the point from the x-axis? 5 units. Look at the second question. If a line has direction ratios 2, minus 1, minus 2, then what are its direction cosines? We have learned what is the relationship between direction ratios and direction cosines, right? So here let's take, let cos alpha, cos beta and cos gamma are the direction cosines, and let A, B, C be the direction ratios. Then cos alpha is equal to A divided by square root of A square plus B square plus C square. Cos beta is equal to B divided by square root of A square plus B square plus C square. Cos gamma is equal to C divided by square root of A square plus B square plus C square. Okay. So here what are A, B and C? Direction ratios. Direction ratios are given, right? So let's find square root of, to find cos alpha, to find direction cosines, here we need to find square root of A square plus B square plus C square. So let's find square root of A square plus B square plus C square, that is equal to square root of 2 square 4. So here let's take A is equal to 2, B is equal to minus 1, C is equal to minus 2. Okay. So A square 4, B square 1 plus C square 4, that is equal to square root of 9, that is equal to 3. Okay. Now let's find one by one direction cosines. Cos alpha is equal to A divided by root of A square plus B square plus C square. A is 2. 2 divided by 3. Okay. And cos beta is equal to B by, what is B? Minus 1. Minus 1 by 3. Okay. And cos gamma is equal to C is minus 2. Minus 2 divided by 3. So these are the direction cosines. If the equation of a line AB is 3 minus x divided by minus 3 is equal to y plus 2 divided by minus 2 is equal to z plus 2 divided by 6. Find the direction cosines of a line parallel to AB. See here we know that direction cosines of parallel lines are proportional, right? So here first of all we need to find direction ratios of line AB, okay? And equation of a line is given in Cartesian form. So first of all we have to check whether given equations are in standard form or not, okay? See here, we know that Cartesian equation of a line is x minus x1 divided by a is equal to y minus y1 divided by b is equal to z minus z1 divided by c. See here it is 3 minus x. So here we have to change. Okay. So equation of a line AB is x minus 3, take minus outside. So x minus 3 divided by minus into minus 3 plus 3. Okay. That is equal to same y plus 2 divided by minus 2. No need to change here because it is in the form y minus y1. Okay. Is equal to z plus 2 divided by 6. Okay. Now here we have direction ratios of AB. Right? Direction ratios of AB 3 minus 2 6. So if there are direction ratios, then we can find direction cosines. Right? So here direction ratios, let A is equal to 3, B is equal to minus 2 and C is equal to 6. Therefore direction cosines of AB are A divided by root of A square plus B square plus C square. Right? That is the relationship between direction ratios and direction cosines. Right? So A divided by 3 divided by root of A square 9 plus B square 4 plus C square 36. And B divided by, that is minus 2 divided by root of 9 plus 4 plus 36. And C 6 divided by root of 9 plus 4 plus 36. That is 3 divided by root of 49, 7. Square root of 49, 7. Minus 2 by 7, 6 by 7 are the direction cosines of AB. Okay, direction cosines of line AB. Here we have to find direction cosines of a line parallel to AB. Therefore, direction cosines of a line parallel to AB are proportional to this direction cosines of AB. Because we know that direction cosines of two parallel lines are proportional. Okay. Therefore, direction cosines of a line parallel to AB are proportional to direction ratios of AB. That is 3 by 7 minus 2 by 7, 6 by 7. Find the angle between the following pair of lines. Minus x plus 2 divided by minus 2 is equal to y minus 1 divided by 7 is equal to z plus 3 divided by 3, and x plus 2 divided by minus 1 is equal to 2y minus 8 divided by 4 is equal to z minus 5 divided by 4. And check whether the lines are parallel or perpendicular. Okay. So here equations of two lines are given. That is these equations are in Cartesian form. Okay. So here don't forget to check whether given equations are in standard form. Okay. See here we have Cartesian equation of a line x minus x1. Okay. So here x minus x1. So we have to change it, right? So x minus x1, for that we have to take x minus outside. So it will be x minus 2, right? X minus 2 divided by, take this minus here. So minus into minus plus, so 2. Okay. Is equal to y minus 1 divided by 7 is equal to z plus 3 divided by 3. And here, and x plus 2 divided by minus 1 is equal to, see here, 2y minus 8. Okay. Y, we have to make it in the form of y minus y1. Okay. So y minus y1. So for that, let's take 2 outside. So 2 outside. So it will be y minus 4 divided by 4 by 2. That 2 we will write here 4 by 2. That is 2. Okay. That is equal to z minus 5 divided by 4. Okay. Now these equations are in standard form. Okay. So here we have to find the angle between these two lines. And these two lines are in Cartesian form, right? So here we will apply the formula for the angle between two lines in Cartesian form. Or you can apply that is vector form, that is vector b1 dot cos theta is equal to vector b1 dot vector b2 divided by modulus vector b1 into modulus vector b2. So for that you have to change this, convert this Cartesian equation to vector equation. Okay, Cartesian form to vector form. Or you can apply directly, you can apply equation in Cartesian form. Okay, that is cos theta is equal to modulus a1 into a2 plus b1 plus b2, b1 into b2 plus c1 into c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. What are a1, b1, c1, a2, b2, c2? Direction ratios of these two lines. That is a1, b1, c1, a2, b2, c2. Okay. So here let's substitute a1 into a2, that is minus 2, plus b1 into b2 14, plus 3 into 4 12 divided by root of 2 square 4 plus 49 plus 9 into root of 1 plus 4 plus 16, that is equal to here 0, right? See, numerator 0 divided by 58 62, root of 62 into root of 21. Okay, that is equal to 0. See, here we have got cos theta is equal to 0. Then what is theta? Theta is pi by 2, right? That is 90 degree. Therefore, theta is equal to pi by 2. That is, angle between these two lines is pi by 2, 90 degree. Therefore, given lines, pair of lines are perpendicular. Okay? Therefore, hence given lines are perpendicular. Find the value of lambda so that lies 1 minus x divided by 3 is equal to y minus 2 divided by 2 lambda is equal to z minus 3 divided by 2, and x plus 1 divided by 3 lambda is equal to y minus 1 divided by 1 is equal to 6 minus z divided by 7 are perpendicular to each other. Here it is given two lines are perpendicular, then what is the value of lambda? Okay, so here also first of all we have to check whether given equations are in standard form. Okay, here equations of two lines are in Cartesian form. So let's write in standard form x minus x1, right? So it should be in the form of x minus x1. Therefore we have to take minus outside. So the equations of a lines are x minus 1 divided by minus 3. Okay, that is equal to y minus 2 divided by 2 lambda is equal to z minus 3 divided by 2, and next equation x plus 1 divided by 3 lambda is equal to y minus 1 divided by 1, and here we have to change, right? So here take minus outside, so z minus 6 divided by minus 7. Okay, now we have to show these two lines are perpendicular. That means cos theta is equal to 0. No, here it is given these two lines are perpendicular. That means cos theta is equal to 90 degree. Sorry, cos theta is equal to 0. That is theta is equal to 90 degree. Cos theta is equal to 0. See, here we have formula cos theta is equal to modulus of a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square, right? That is equal to 0, right? If two lines are perpendicular to each other, then cos theta is equal to 0, right? So cos theta is equal to 0 implies this one is equal to 0. That is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So that we will get the value of lambda. Okay. So let's find a1 a2. See here These are the direction ratios of this line, and 3 lambda, 1, minus 7 are the direction ratios of this line, right? That is A1, B1, C1, A2, B2, C2. Okay, now let's find A1, A2 plus B1, B2 plus C1, C2. Okay, let's substitute here. That implies A1, A2, that is minus 9 lambda plus B1, B2 plus 2 lambda plus 2 into minus 7 minus 14, that is equal to 0. That implies here minus 7 lambda minus 14 is equal to 0. That implies 7 lambda is equal to minus 14. That implies lambda is equal to minus 14 divided by 7, that is minus 2. So value of lambda is minus 2. Write the vector equations of the following lines and hence determine the distance between them. X minus 1 divided by 2 is equal to y minus 2 divided by 3 is equal to z plus 4 divided by 6, and x minus 3 by 4 is equal to y minus 3 by 6 is equal to z plus y divided by 12. Okay. So here two equations of two lines in Cartesian form are given. So here first of all we have to write, that is we have to convert this Cartesian form to vector form. Okay. So here first of all let's write vector equation of a line. Vector r is equal to vector a1 plus lambda vector b1. Okay. Suppose these two lines, it is the equation of Cartesian equation of a line L1 and Cartesian equation of a line L2. Okay. So it is the vector equation of line L1 and vector equation of line L2 is vector r is equal to vector a2 plus mu vector b2. Okay. So here what is vector a1 and vector b1? Vector a1, here we know that this line is passing through the point 1, 2, minus 4. Okay. So vector a1 is I plus 2j minus 4k. Right. And vector b1, that is vector b1 is the parallel line, right? Parallel to this line. Okay. Therefore vector b1 is equal to, these are the direction ratios. So vector b1 is 2y plus 3j plus 6k. Okay. And here vector a2 is equal to 3i plus 3j minus 5k. Vector b2 is equal to 4i plus 6j plus 12k. Okay, so here let's write these equations in vector form, that is vector r is equal to, first equation means equation, vector equation of line L1 is vector r is equal to vector a1 I plus 2j minus 4k plus lambda into vector b1 2y plus 3j plus 6k. And vector r, that is vector equation of line L2, vector r is equal to 3i plus 3j minus 5k plus mu into 4i plus 6j plus 12k. Okay. Now here we have got vector equations of these two lines. Okay. Next is we have to find distance between them. Okay, let's find the shortest distance between them. Okay, that is shortest distance is equal to vector a2 minus vector a1 dot vector b1 cross vector b2 divided by modulus of vector b1 cross vector b2. Okay. So here we need to find vector b1 cross vector b2, right? So vector b1 cross vector b2 is equal to determinant I, j, k 2, 3, 6, 2, 3, 6, 4, 6, 12, 4, 6, 12. That is equal to I into here 36 minus 36 minus j into 24 minus 24 plus k into 12 minus 12. See, here we have got vector b1 cross vector b2 is equal to 0. See, here we noticed that vector b1, see vector b2 is the scalar multiplication of vector b1, right? That means vector b1 and vector b2 are parallel. Okay. So here we know that if that is cross multiplication of two lines, two vectors are 0. Okay. Cross multiplication of two vectors is 0. Right. So here we have got a vector b1 cross vector b2 is 0. Right. Therefore, shortest distance we will get after substituting vector b1 cross vector b2 is equal to 0. Here we will get shortest distance is 0. See, shortest distance between two lines is 0 means these lines are intersecting or these are the same line. Here we cannot say these two lines are intersecting. Why? Because see, vector b1 and vector b2 are parallel. Okay. Vector b1 and vector b2 are parallel. See, this vector b1 parallel to this vector, right? This line. Okay. This line is parallel to this line, vector r. And vector b2 is parallel to vector r, right? And vector b1 parallel to vector b2. Therefore, here vector b1, these two lines are not intersecting. Therefore, here we can say these two lines are the same line. Okay, because here we have got shortest distance is equal to 0. Therefore, here we can say these two lines are the same line. Given the straight lines, vector r is equal to 3i plus 2j minus 4k plus lambda into i plus 2j plus 2k, and vector r is equal to 5j minus 2k plus mu into 3i plus 2j plus 6k. Here, first question, find the angle between the lines. Okay, so first of all, let's answer the first question. Find the angle between the lines. See here, given lines are in vector form. Okay, therefore, let's find the angle between these two lines using vector form, equation of vector form. Cos theta is equal to vector b1 dot vector b2 divided by modulus of vector b1 into modulus of vector b2. That is equal to, here what are vector b1 and vector b2? See here, it's of the form vector r is equal to vector a1 plus lambda vector b1, and vector r is equal to vector a2 plus mu vector b2. So it is vector b1, it is vector b2, right? So vector b1 is I plus 2j plus 2k dot vector b2 3i plus 2j plus 6k. Divided by modulus of, that is square root of, here quotient of I 1 square 1 plus 4 into root of 3 square 9 plus 4 plus 36, right? That is equal to 1 into 3 plus 2 into 2 4, 2 into 6 12. Divided by root of 8 plus 1 9 into root of 49. That is equal to, that is 19 divided by 3 into 7 21. Okay. So 19 by 21. So here that implies theta is equal to, cos theta is equal to 19 by 21. So theta is equal to cos inverse of 19 divided by 21. So it is the angle between them. Okay, so angle between these two lines is cos inverse of 19 by 21. Next, let's find second question. Obtain a unit vector perpendicular to both the lines. Second one is obtain a unit vector perpendicular to both the lines. Okay, see here, we know that this vector b1 parallel to this line, right? And vector b2 parallel to this line. Here we have to find, okay, leave this unit vector, we have to find a perpendicular vector, a perpendicular line that is perpendicular to, a line perpendicular to both of these lines. Okay, since this b1 perpendicular to this line, b2 perpendicular to this line, it is enough to find a line perpendicular to both of these lines. Okay, vector b1 and vector b2. So what is that vector? That is vector b1 cross vector b2. Because we know that vector a cross vector b is perpendicular to both of vector a and vector b. Right? Vector a cross vector b is perpendicular to both vector a and vector b. Right? So here it is vector b1 cross vector b2 is perpendicular to both of these vectors. Therefore, vector b1 cross vector b2 is perpendicular to both of these lines. Because this one will parallel to this line, this one parallel to these lines. Therefore, here b1 cross b2 is a line perpendicular to both of these lines. Okay, so here we have to find unit vector. Okay, we know that how to find unit vector of a vector, right? So here we have to find unit vector perpendicular to both of the lines. That is nothing but vector b1 cross vector b2 divided by modulus of vector b1 cross vector b2. So second one, that is unit vector perpendicular to both the lines is vector b1 cross vector b2. It is the line perpendicular to both of these lines, right? And we have to find unit vector, therefore divided by modulus of vector b1 cross vector b2. So let's find vector b1 cross vector b2. Vector b1 cross vector b2 is equal to modulus, determinant I, j, k, 1, 2, 2, 1, 2, 2, 3, 2, 6, 3, 2, 6. Okay, that is equal to I into 12 minus 4 minus j into 6 minus 6 plus k into 2 minus 6. Okay, that is equal to, see here, that is 8i, it is 0, minus 4k. Okay, see here it is vector b1 cross vector b2. So it is the vector perpendicular to both of these lines. Okay, it is the vector perpendicular to both of these lines. So here unit vector perpendicular to both of these lines is vector b1 cross vector b2 divided by modulus of vector b1 cross vector b2. That is 8i minus 4k divided by root of 8 square 64 plus 4 square 16. That is equal to 8i minus 4k divided by root of 80. Okay, then here now we have got a unit vector perpendicular to both the lines. Okay, now let's go through third one. See, form the equation of the line perpendicular to the given lines and passing through the point 1, 1, 1. See, again here we have to form an equation of a line. What is the equation of a line of the form? Vector r is equal to vector a plus lambda vector b. Okay, and here this vector b is parallel to this line, right? And see here, it is the vector perpendicular to both of these lines. Okay, see here we have to find the equation of the line perpendicular to both of these lines, right? Therefore here vector b is nothing but 8i minus 4k. Okay, because it is parallel to this line. Okay, so here that is vector r and passing through the point 1, 1, 1. Therefore vector a is I plus j plus k. Therefore vector required line vector r is equal to I plus j plus k plus lambda into, okay, see it is the vector parallel to required line. Okay, because it is the vector perpendicular to both of these lines. Here we have to find the equation of a line which is perpendicular to both of these lines. Okay, therefore it is, this vector is parallel to required line. Okay, so lambda into 8i minus 4k. It is the required equation of line. Look at the next question. Find the foot of the perpendicular from the point 0 to 3 on the line x plus 3 by 5 is equal to y minus 1 divided by 2 is equal to z plus 4 divided by 3. Also find the length of the perpendicular. Okay, so here we have to find a point of the perpendicular from the point 0 to 3. Okay, this point is on the line x plus 3 by 5 is equal to y minus 1 by 2 is equal to z plus 4 divided by 3. Suppose, see, it is the line, okay, it is the line x plus 3 by 5 is equal to y minus 1 divided by 2 is equal to z plus 4 divided by 3. Okay, suppose it is the point 0 to 3. Okay, we have to find foot of the perpendicular from this point. So this point we have to find. Okay, so here let Q be the foot of the perpendicular from the point. Let's take this point to be P. Okay, from the point P of 0 to 3. On the line, see, you have to check whether this line is in standard form. This line is in standard form, therefore equation is in standard form, therefore no need to change. Okay, on the line x plus 3 by 5 is equal to y minus 1 by 2 is equal to z plus 4 divided by 3. Okay, so that is equal to lambda. Say it is lambda. Okay, now let's find x coordinate, y coordinate, z coordinate, that is x, y, z values. So here, that is coordinates of Q is here x coordinate is 5 lambda minus 3, 5 lambda minus 3, 2 lambda plus 1, z coordinate 3 lambda minus 4. Okay, so it is the point 5 lambda minus 3, 2 lambda plus 1, 3 lambda minus 4. Okay, so here we have to find this point, right? So for that we need to find the value of lambda. Okay, so for that, here see, let's find direction ratios of this line. Here we know that what are the direction ratios of this line? That is 5, 2, 3. 5, 2 and 3 are direction ratios of this line. How to find direction ratios of this line, perpendicular line? That is, we know that direction ratios of a line joining 2 points, suppose it is x1, y1, z1, x2, y2, z2, is x2 minus x1, y2 minus y1, z2 minus z1 are the direction ratios of a line joining 2 points x1, y1, z1, x2, y2, z2, right? So here direction ratios of PQ, direction ratios of PQ are 5 lambda minus 3 minus 0. Next, 2 lambda plus 1 minus 2, 2 lambda minus 1. 3 lambda minus 4 minus 3, 3 lambda minus 7. These are the direction ratios of PQ. And direction ratios of this line is 5, 2, 3. And these two lines are perpendicular. Right? We know that if two lines are perpendicular, then A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Right? What are A1, B1, C1, A2, B2, C2? A1, B1, C1, A2, B2, C2 are the direction ratios of these two lines. Right? So, if two lines are perpendicular, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Right? So, let's find what is A1. Let's take these are A1, B1, C1, A2, B2, C2. Okay. So, 5 into this, sorry, it is not A2, B2, C2. It is the coordinates, okay, a point Q. These are the direction ratios of PQ. Okay. Direction ratios of this line is 5, 2 and 3. Direction ratios of PQ are 5 lambda minus 3, 2 lambda minus 1, 3 lambda minus 7. So 5 into 5 lambda minus 3 plus 2 into 2 2 lambda minus 1 plus 3 into 3 lambda minus 7 is equal to 0. That implies here 25 lambda minus 15 plus 4 lambda minus 2 plus 9 lambda minus 21 is equal to 0. That implies 25 lambda plus it is 29, 29 plus 9, 38, 38 lambda minus 15 minus 17, minus 17 minus 21 minus 38. So minus 38 is equal to 0. This implies lambda is equal to 1. See, we have got the value of lambda, that is 1. So let's substitute this lambda is equal to 1 in this coordinates. We will get the point Q, that is foot of the perpendicular. Okay. So here, therefore Q is, coordinates of Q is 5 into 1 minus 3, that is 2. Okay. 2 into 1 plus 1, 2 into 1, 2, 2 plus 1, 3. And 3 into 1, 3, 3 minus 4, minus 1. Okay. Therefore, foot of the perpendicular from the point is 2, 3 minus 1. And what is the distance? Here we have to find the length of the perpendicular. See, length of this line, that is PQ. Distance PQ. That is length of the perpendicular is equal to square root of, what is the distance between these 2 points? 0, 2, 3, and this point is 2, 3 minus 1. So 2 minus 0 square, that is 2 square, 4, plus 3 minus 2 square, that is 1, plus minus 1 minus 3 minus 4 square, 16, that is equal to square root of 21 units. Okay. Square root of 21 units. So length of the perpendicular is square root of 21 units. Find the equation of the line passing through the point minus 1, 3, minus 2 and perpendicular to the lines x by 1 is equal to y by 2 is equal to z by 3 and x plus 2 divided by minus 3 is equal to y minus 1 divided by 2 is equal to z plus 1 divided by 5. Okay, so here we have to find a line, okay, equation of a line which passes through the point minus 1, 3, minus 2 and which is perpendicular to both of these lines. Okay, see, if you are confusing in Cartesian form, you just convert this Cartesian form to vector form. Okay, see, here I will write these two equations of, that is vector equation of these two lines. Vector r is equal to vector a, here vector a is 0. Okay, that is 0 vector plus lambda into direction ratios 1, 2, 3. Therefore, vector b1 is I plus 2j plus 3k. Okay, and here vector r is equal to vector a2, that is 2i, okay, minus 2i plus j minus k plus mu into vector b2 is minus 3i plus 2j plus 5k. Okay, then after that, see here we have to find equation of a line which is perpendicular to both of these lines, right? And we know that this vector is parallel to this line and this vector is parallel to this line. Okay, so here it is enough to find the a perpendicular line which is perpendicular to both of these vectors. That is, suppose it is vector b1, it is vector b2, then vector b1 cross vector b2 is perpendicular to both of this vector, right? That is, vector b1 cross vector b2 is perpendicular to both of these lines. Okay, so here let vector b1 is equal to I plus 2j plus 3k and vector b2 is equal to minus 3i plus 2j plus 5k. Okay. Then vector b1 cross vector b2. Here vector b1, this vector b1 is parallel to this line and vector b2 parallel to this line. Here we have to find a line which is perpendicular to both of these lines. So it is enough to find a line which is perpendicular to both of these two lines, these two vectors. Okay, that is vector b1 cross vector b2. So vector b1 cross vector b2 is equal to determinant I, j, k 1, 2, 3 minus 3, 2, 5. That is equal to I into 10 minus 6 minus j into 5 plus 9. 5 minus minus 9, that is 5 plus 9 plus k into 2 minus 6, right? 2 minus minus 6, 2 plus 6. That is equal to 4i minus 14j plus 8k. See, it is the vector perpendicular to both of these lines. Okay, it is the vector perpendicular to both of these vectors. Therefore, it is perpendicular to both of these lines. Here what we have to find? We have to find equation of the line which is perpendicular to both of these lines and it is passes through the point minus 1, 3, minus 2. Again we have to make equation of the line, that is vector r is equal to vector a plus lambda vector b. Here vector b is, what is vector b? This one. Okay, because it is parallel to the required line. Okay, it is perpendicular to these lines, both of these lines. Therefore, it is parallel to this line, required line. Okay. So here, what is vector a? Vector a is nothing but minus I. See, vector a is equal to minus I plus 3j minus 2k. And vector b is equal to 4i minus 14j plus 8k. Okay. Therefore, equation, see here it is better to write the equation in Cartesian form. First of all, you write it in vector form, then convert it into Cartesian form. Okay. So let's write vector equation. Vector r is equal to vector a, that is minus I plus 3j minus 2k plus lambda into 4i minus 14j plus 8k. Okay. It is vector equation. Because since these given equations of lines are in Cartesian form, it is better to write in Cartesian form. Okay. So let's write required equation of a line is x minus 1. That is the point. Okay. Plus 1 divided by so where is vector b? Yes, 4. Okay. 4, that is equal to y minus y1, that is y minus 3 divided by minus 14 is equal to z minus 2, that is z plus 2 divided by 8. Okay, because this vector is parallel to required line. Okay, therefore their coefficients are the direction ratios. Okay, direction ratios of this line. Okay, so it is the required equation of line. Find the direction cosines of the line x plus 2 divided by 2 is equal to 2y minus 7 divided by 6 is equal to 5 minus z divided by 6. Also find the vector equation of the line through the point a of minus 1, 2, 3 and parallel to the given line. Okay. See here first question is finding the direction cosines of the line. Okay. Here equation of the line is in Cartesian form. Okay. Therefore, see first of all here we have to check whether this equation is in standard form or not. See here 2y minus 7. See actually here it will be y minus, it should be y minus y1 divided by b, right? So here we have to change. Therefore, given equation of the line is x plus 2 by 2 is equal to, here take 2 outside. So y minus 7 by 2 and write this 2, 6 by 2, so it is 3, okay. That is equal to, here it should be in the form z minus z1, therefore take minus outside, z minus 5 divided by minus 6, okay. Now we have to find the direction cosines, right? See here we know that relationship between direction cosines and direction ratios. Here we will get direction ratios of this line. 2, 3, minus 6 are the direction ratios, right? Right? Direction ratios of the line are 2, 3, minus 6. Therefore, direction cosines of the line are 2 divided by root of 2 square plus 3 square plus minus 6 square. 2 square 4, 3 square 9 plus 36. 3 divided by root of 4 plus 9 plus 36 minus 6 divided by root of 4 plus 9 plus 36. That is 2 divided by 36 plus 4, 40, 49, root 49, 7. 2 by 7, 3 by 7 minus 6 by 7 are the direction cosines of the given line. Okay. Next question is, find the vector equation of the line through the point A of minus 2, minus 1, 2, 3 and parallel to the given line. Here we have to write the equation of the line which is parallel to this given line. Okay, which is parallel to this line. Okay, see here. See, if you are confusing, you just write it in, okay, it is the equation. You just write it in, convert it in vector form. That is, vector r is equal to, equation of this given line in vector form, vector r is equal to vector a, that is minus 2i plus 7 by 2j plus 5k plus lambda into vector b is 2i plus 3j minus 6k. Okay, it is the vector equation of the given line. Okay, so here we know that this vector is parallel to this line, right? That is 2i plus 3j minus 6k is parallel to this line. Therefore, it is parallel to required line also, because we have to find the equation of the line which is parallel to this line. Therefore, this line is also parallel to required line. Okay. Therefore, here we have to form equation, vector equation of the required line, that is vector r is equal to vector a plus lambda vector b. And this line passes through the point minus 1, 2, 3. Therefore, vector a is minus I plus 2j plus 3k. Okay. Plus lambda into what is vector b? The same vector. Okay. Because this vector is parallel to this line. Therefore, since we have to find the vector, that is line parallel to this line, okay, therefore it is the vector b here. Okay. So here 2i plus 3j minus 6k. So this vector is also parallel to this required line also. Okay. Therefore, the required equation, vector equation of the line is vector r is equal to minus I plus 2j plus 3k plus lambda into 2i plus 3j minus 6k.